Have you ever wondered why the same SV code sometimes gives unexpected simulation results? Even when the logic looks correct and simple process running at the same time can create race conditions and timing issues. That's exactly why SVN uses scheduling semantics. Here, in this flow of SV scheduling semantics, inside single simulation time slot, whenever multiple processes run simultaneously in SV, the simulator follow the order regions to decide which operation executes the first and how signals are updated. Here, at the beginning of the time slot, the simulator enters into the prepone region. Here, where concurrent assertion sample signal value before any update occur. This ensures assertion capture stable signal data. After that comes to the pre-active region, mainly used for PLI callback operation before normal execution starts. The next and most important region is the active region. Here, the most RTL activity happens, including blocking assignments, continuous assignment, dollar display execution, primitive evaluation, and evaluation of the RHS of non-blocking assignments. For example, A less than or equal to B. The value of B is calculated in the active region, but A is not updated. This separation is important to avoid race conditions. After that, active region. The simulator moves into the inactive region here, which executes hash zero delay statements. Then the pre-NBA region prepares for non-blocking assignment updates. In NBA region, the actual LHS updates of all non-blocking assignments occurs. This is why non-blocking assignments are ideal for sequential logic because all register update happen together in a synchronized manner. Next comes post-NBA region, followed by the pre-observed and observed regions. In the observed region, the concurrent assertion that were sampled earlier or evaluated. This allows assertion to compare old and updated values correctly. After the assertion evaluated, the simulator enters into the reactive region, where program block and test bench reactions execute. This separation between DUT execution in active region and test bench executes in reactive region prevents DUT test bench race conditions. Finally, the simulator enters into the postpone region, here, which is the last phase of the time slot. Commands like $monitor and $stop execute here after all signal updates are complete. Functional coverage collection also typically occurs in this region. Once all regions are completed, the simulator moves to the next simulation time slot. Have you ever wanted to see all SV scheduling regions work together in one simulation example? Here, this code is a perfect demonstration of how the simulator executes different operations across active, inactive, NBA, observed, reactive, and postpone regions. Here, in this example, the module contains signals ABCD and a clock CLK. The clock toggles every 5 time units using always block, which continuously generate positive and negative clock edges. Here, initially A is assigned to 0 and B is assigned to 1. After 10 time units, the blocking assignment A equal to B executes. Since blocking assignment executes immediately in the active region, the value of A changes instantly and the $display statement also executes in the same active region, printing the updated values of A and B. The always at the rate of passage clock demonstrate non-blocking assignment behavior. At every positive edge of the clock, C non-blocking of A and D non-blocking of B are executed. In SV scheduling semantics, the RHS values of A and B are immediately evaluated immediately in the active region, but the actual updates of C and D are postponed of the NBA region. This separation between RHS evaluation and RHS update in the main reason of non-blocking assignments to avoid this condition in sequential logic. The display inside the block confirms the RHS evaluation occurs in the active region. Another important concept shown here is the inactive region. The statement #0 $display introduces a zero time delay. Dollar in SV #0 delays move execution from the active region into the inactive region. So this display executes only after all active regions, even complete within the same simulation time slot. The assertion property P1 demonstrates assertion scheduling behavior. Concurrent assertion sample signals in the prepon region before updates occur and evaluate them later in the observed region. If the assertion passes or fails, the corresponding action block executes in the reactive region. This separation ensures assertion work with stable sample values and prevents race conditions between DUT and assertion evaluation. Finally, the $monitor statement demonstrates the postpone region. $monitor executes at end of the simulation time slot after all signal updated or completed, which is why it prints the final stable evaluation of C and D. The simulation continues until $finish executes at time 100. Here overall the simulation output demonstrates how SV scheduling regions execute in an order manner within a simulation time. At, at time 0, monitor executes in the postpone region and prints unknown values because C and D are uninitialized. At 5, the positive clock edge triggers the always at the rate of postage clock block where the RHS of non-blocking assignment is evaluated in the active region. Since A equal to 0, the assertion A implementation C automatically passes in the observed or reactive region. After that, NBA region updates C equal to 0 and D equal to 1 and $monitor prints the final stable values in the postpone region at time 10. The blocking assignment A equal to B executes immediately in the active region, making A equal to 1, while the #0 delayed statement executes later in the inactive region. At time 15, the assertion fails because A equal to 1, but C still contains the old value 0 before NBA update occurs. Then the NBA region updates C and D equal to 1 and the postpone region prints the updated values from time 25 onwards. Both A and C remain 1, so the assertion passes at every clock edge. Overall, this example clearly demonstrates active inactive NBA observed reactive and postponed scheduling regions show how SV avoids race condition using ordered event execution.